number 40. The first thing you need to do is balance it, and it is not that hard to balance. If you know the boiling point of water in Fahrenheit, that's the answer. I'm sure that was helpful. Jules knew it. Okay, so here we go. This problem is Mg plus O2 goes to MgO. In order to balance this, you need 2 oxygens. So you put a 2, that makes 2 Mgs, and you get 212, which is 212, which obviously is the boiling point of water, correct? Everyone knows that. Okay, no one does, but whatever. I do, because I have a book about the boiling point of water. I think I threw it away. It was a fascinating read. Okay, now, after we balance, then we set the picket fence up by following the same steps we did yesterday. So if you don't need my help, just ignore me and do it on your own. If you think you still need my help, which I think most of you still do, then do this with me. So, what do we start the top left-hand corner with? Not the moles, not the grams. It could be either one. It's the given, right? So in this particular problem, it says if 35 grams of magnesium. So I start the top left corner with the number and unit that I have been given. 35 grams of Mg. Then the nice thing about the picket fence is that the unit up top always goes where? Over and down. So on the bottom I have grams of Mg. And then please repeat with me. Are you ready? Grams. Grams are always per 1 mole of the same thing. Okay, look right here. You don't have to repeat with me now. Grams are always per 1 mole of the same thing. Your grams and moles in a picket, they have to be the same chemical. Okay, now, if I know the top left, I also know the bottom right, correct? So what unit must go there? Tell your lab partner, please. Okay, very good. I heard some mumbling. You mumbled moles of Mg. Now stop. Is there anything here that tells us what goes there? Not yet, right? So when we get to that point, we always have to go and work our way backwards. So what does this want you to solve for? Moles of which thing? MgO. So what goes here then? Mole MgO. Love. All right, now let's review here. How on earth? Well, first, moles of Mg, that number's right here. So it's a 2. Moles of MgO is right there. It's also a 2. So that step mathematically didn't matter. Science-wise it did, but mathematically it did not. Okay, now, to find the grams of Mg, you use the middle periodic table. So will you all open that? I'll borrow that one. Okay. In the middle periodic table, it will have your molar masses listed for every element. So show your lab partner where magnesium is and what the mass is. You got one? Okay. Bless you. All right, magnesium is right here. I mean, that's supposed to be an Mg. 24 and 12, right? Which one is the one I care about? The 24. Thank you. So I'm going to put 24 right here. And then mathematically, what happens, math, if you have a 2 and a 2. It's just 1, right? So don't waste your time. So this is 35 divided by 24. Will you type that in? I heard 1.458, which I would call 1.46. Is that okay? Thank you. Okay. Not that bad, is it? Okay, it's terrible. Never mind. Who thinks it's not that bad? Who thinks it's terrible? Who thinks it's both? Can't be. Whatever. I guess it's America. We can be what we want to be now. All right, look at number 41. 41 is odd because the words are at the bottom of page 14, but the space to do it is on the top of page 15. I apologize for that editing snafu. All right, so here we go. I will help you with the chemistry, and then I want you to try it yourself. So we have lithium reacting with water, and it makes lithium hydroxide and H2. Okay, you try and balance it. And you try and do the periodic table, or sorry, the picket fence. And we'll just go. So we're going to keep following this same exact process every time. Are you ready? So 10 grams of Li, which means what's on the bottom right there? It's going to be grams of Li. Thank you for participating. All right, and everyone in the class, anytime you have grams, it's per what? 1 mole of the same substance. 1 mole Li. That's important to know because then that tells us the bottom of that one, right? If this one's mole Li, then this one is also moles Li. All right, and then it's the part where you don't know what comes next, so you come to the end, and you're solving for moles of which thing? Hydrogen gas, which is the H2. That means over here you have mole of H2. And then we would plug it in. I didn't balance on accident. 2, 2, 2, 2. So 2, 2, 2, 1. So over here I have 2 Li's. 2 every 1 H2. And the final step is to find the mass of Li, and that's just the bigger number in Li, which is 7. So you end up with 10 divided by 14, which ends up to be 0.714. Moles of H2. We all right with that? Okay, the reason most people get the next one wrong is because it's backwards. I've taught you how to do something, and you've memorized how to, well, you didn't memorize. You're going to look and try and make it fit into what we just did, but we don't. So look at the screen for a minute. What we did here is I gave you grams, and I asked you to solve for moles. To do that, we had to go from the grams that were given to me to the moles that were the same as those, and convert it to the moles of the other thing I wanted. Sort of okay? This time, this next problem, I'm going to give you moles and ask you to find the grams. It's the same process, but it's flipped. So when you do number 42, don't force it to match number 41 because it doesn't, because it's backwards. I'll help you with the chemistry, then you try the stoichiometry. So barium chloride reacts with sodium sulfate. So barium chloride is BaCl2. Sodium sulfate is Na2SO4. And it makes BaSO4 plus NaCl. It's already, like I did all the dropping and swapping. So you just need to balance. And you need to do the picket fence. And to save you some time, please look. You only need the mass of BaCl2. If you think you need something else, then you're doing it wrong. The mass of this is 208 grams. That'll save you some time of adding up. Okay, ready? Go. This together. First off, how many of you got 728? Raise your hands. 1, 2, 3, 4, 5, 6, 7, 8. You're all wrong. JK, you're all right. I just wanted to offend Danielle. You should be. I'd still be offended from prom, personally, if I were you. But, okay, good. All right, now that we're both offended, we start with the number and unit I gave you, right? Was this the 3.5 moles? It's been a long day. 3.5 moles of Na2SO4. Now, please learn the process. Don't memorize the parts. So the process says whatever unit's here goes there. So I need mole Na2SO4. That's ugly, but I don't care. All right. Is there anything that tells me what goes in this box right now? So right now, there's nothing on here that tells me. What do I do when I'm stuck? Go to the reverse. Thank you. What did I ask you to solve for? Grams of BaCl2. And the unit at the end always matches the unit at the end. And anytime we use grams, it's per what? 1 mole of the same species. 1 mole BaCl2. And if I know this, then I know that. Mole BaCl2. And so now I have all the parts. I just need to plug it in. I never balanced here, but it turns out it's 1, 1, 1, 2. So both of these are just ones. And I know mathematically that seems like a waste of time. And it is mathematically. But chemistry-wise, we're making sure we get the correct units. These are not always ones, so it is important. All right, and then BaCl2 grams, that's why I gave you 208 right there. And then we do math, and it was 728. Is that correct? All right. If you did it wrong and got the right answer, that's acceptable today on this one because they were both ones, probably. But when they're not, you screw up, you're screwed up. I don't know. What do you think? How many got that right again? 5 of you? Oh, a lot of you. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's good. Okay. What we're going to do now, we're going to go back to the notes and learn gram to gram, which most people like the best because it never is different. This one, you go one way or the other, right? Gram to gram is gram to gram. So you go the same way no matter what you're doing. So turn back to page number 11 now, correct? We're at the top of page 11, which is grams to grams. The first thing I need you to do is balance that equation. All right, I heard someone mumble the 2, 3 swaparoo. That is correct. Nice. Okay, the majority of the front row is done, so we'll think most of you are. You see a 3 and a 2, so you swap the 3 in front of the 2 in front of the 3, and that makes that a 4. 4, 3, 2. Then, please notice the picket fence is now longer because we're going from grams to grams, and it takes one extra step. All right. So, same process, though. And remember, this is what's awesome. Whatever unit is here is there. Arrow overload today, probably. You count however you want. You're the accountant. All right. So, if you will accept that the units always go across and down, at the last unit matches your last unit, you're going to be golden. So here we go. I always start with the number and unit that I was given, which is 79 grams of aluminum oxide. Okay, that means the bottom of the next picket is what? All right, the same thing, which is grams of Al2O3. And that would mean that the top of that picket is what unit? 1 mole of the same thing. You got it? I'll get it for you next time. All right. And if you know the top, you must know the bottom because they're the same every time. So on the bottom is mole Al2O3. But then you're stuck. So what do we do when we're stuck? We go backwards. So what am I solving for? Grams of Al. Okay, well, we know the units on the end and the end are the same, so grams of Al. Grams are always per what? 1 mole of the same thing. And now if I know the bottom, I know the top. It has to be the same. Mole, Al. And then I plug stuff in. The mole and the mole, they simply come from here. So there's a 4 in front of the Al. There's a 2 in front of the Al2O3. And then I have to find the masses, correct? Aluminum's easy because there's no math with that. You look that up, and it is 27. And Al2O3 does require more effort. There are 2 aluminums, and each one's 27. Plus, there are 3 oxygens, and each one of those is 16. 102, is that this one? And we end up with 102, which is what goes right here. Then, I would check to see if I can reduce anything in the picket fence, and I can, right? I have a 4 over a 2, which really reduces to a what? A 2 over a 1. That saves me some calculating. So the answer would be 79 times 2 times 27, and then divide that by 102. And this one I can't remember. 40? Is that this one? 40.8? 41? Okay, 41.82. There we go. That's a cute circle. Okay, did that seem awful? Good. No, it's not supposed to be awful. It's a lot of steps, but none of the steps are really that hard, I hope. All right, let's turn and do whatever. Number 43. Do not do the 2-3 swap because you don't need to. Do what I call the 1-1-1 swap. There, it's already balanced. Then let me save you some time. The 2 masses you need for MgCO3, it is 84 grams. For MgO, it's 40 grams. Okay, you try the picket fence. It should look a lot like this one. Whoops. First off, is this one the 9.5? So how many had 9.5 as your answer? Okay, then you're fine. I'm going to do it anyway. 10 grams of what? This one? 20? Sorry. 20 grams of MgCO3. And that was then grams, and that's 84. I gave it to you, of MgCO3. And grams is always per 1 mole of the same thing, MgCO3. That means that unit down there would be what unit? Mole, MgCO3. Then that's where I get stuck. So I come back and I'm asking you for grams of MgO, which is the unit at the end. MgO. What am I doing? Grams, MgO. And grams is always per 1 mole of the same thing, MgO, which means I now know that unit is mole, MgO, and I'm ready. The coefficients are all 1s, so that's easy. MgO I gave you was 40. So plug all that stuff in. 20 times 40 divided by 84 is 9.5. Okay, raise your hands if you feel okay with this. I know it's a lot of steps, but I don't think each individual step is super hard. Okay, the chemistry on number 44, AuCl3 goes to Au plus Cl2. I would balance that using a 2-3 swap. 2, and then 3 goes in front of the 2, 2, and then you're off to the races. Look, you will need this number. This used to be a band. This is 303. Might be a band still, I don't know. And then you need gold, which is 197. Okay. Fire away. This is the longest one. Yeah. And then I ruined it with the line tool. Yeah. That's about to fall off. There we go. So here we go. What did I give you? 60 grams of AuCl3. That means grams AuCl3. That was 303. All right. And then grams is always per 1 mole. How am I doing on my arrows? That's weak. All right. All right. There, we'll make my equal sign a double-line arrow. Grams of Au, which means what here? Grams of Au, which means what here? 1 mole of Au, which means what goes up here? Wow. What do we got? Mole of Au. I thought it was pretty creative, personally. All right, then. What do we have? What is our numbers here? All right, a 2 and a 2. Okay. And then 97, 197. $197. All right, the 2 and 2s can be reduced to just a 1. And then we're ready to roll. We get 39. Okay. Okay, who had that right? Thank you. Are we okay? This is really not that bad, I hope. You think you learned it? I think you probably did too. OMG.